Did you know that it's possible to land on Venus without a parachute or even a rocket engine? This is a unique feature of the planet, discovered by the Soviet Union 5 decades ago. It was the result of a trial and error process that finally revealed the truth about the most interesting location in our solar system. This is what the Soviets found when they landed on Venus and why they never went back. Venera is the Russian word for the planet Venus. It's also a series of 16 missions that sought to understand, discover, and map out Earth's closest neighbor. Dating back to 1961 and extending all the way to 1985, the Venera project was a series of space probes and satellites sent to Venus that would study the planet and gather more information. Ostensibly, this was done for science, but we can't ignore the political implications either, one of many ambitious plays by the USSR to assert itself as a more capable actor during the space race. While Mars tends to get all of the attention in the 21st century, back in the day there was actually much more interest in studying Venus. Why is that? Well, we can observe the surface of Mars through high-powered telescopes on Earth, so we had a pretty good idea that there wasn't a whole lot going on over there. Aside from a minority of fringe theories about canals on Mars, it was generally accepted to be a dead planet. But Venus, on the other hand, presents a centuries-old mystery. All that we can see from Earth is an impenetrable, unyielding cover of thick clouds. So what lies beneath? If Venus has clouds, then it has a dense atmosphere, unlike Mars, which means that there could be life on Venus. The closer proximity to the Sun, combined with the insulating cloud layer, would indicate that it must be hot on Venus. A tropical climate that spans an entire globe, covered with dense rainforests that support all manner of alien insects and reptiles, like a prehistoric Earth. This was more plausible than the Martian theory, but even still was not widely regarded by the scientific community of the day. The famous astronomer Carl Sagan had already popularized the notion that the unbreaking cloud cover of Venus was indicative of a greenhouse effect that had gone wildly out of control and superheated the planet, meaning that the world below the clouds would be nothing more than a scorched hellscape. But there was only one way to find out. As with all of the early milestones in the space race, the Soviet Union was the first to make an attempt to study Venus up close. The year was 1961. The Soviets built 2 probes, Venera 1 and Venera 2. This was a common procedure in the first decades of space exploration to launch missions in pairs, because there was still a very high likelihood that one of them was going to fail. You really have to appreciate the ambition of these primitive interplanetary flights. With nothing more than an adding machine to guide them, the Russian engineers strapped a rocket engine to their probe, loaded it on top of a ballistic missile called the R-7, and set course for Venus. Then they let it rip and hope for the best. The good news is that both probes were able to fly within 100,000 kilometers of Venus. The bad news is that both probes experienced a full system failure before reaching their destination, and therefore no usable data was returned. Then in 1962, the Americans succeeded where the Soviets had failed. Their Mariner 2 probe flew within 35,000 kilometers of Venus and completed the first up-close observation of another planet. During a 42-minute scan of Venus, Mariner 2 gathered significant data on the Venusian atmosphere and the surface from both the night and day sides. The findings confirmed Sagan's theory about the greenhouse effect. Mariner 2's microwave radiometer indicated temperatures of up to 475 degrees Celsius on the day side. Mariner 2 also found that there was a dense cloud layer that extended from 56 to 80 kilometers above the surface. Based on this data, NASA largely decided to pass on further exploration of Venus in the short term, considering it an environment totally inhospitable for either man or machine. So they switched focus to the Moon and Mars. But the Soviets were less convinced. They redoubled their efforts and prepared the second wave of Venera probes. They still had no idea just how bad things were about to get. It's 1966, and the Soviets have built a bigger and tougher spacecraft for Venera 3 and 4. It's now weighing in at over 2,000 pounds, equipped with a variety of instruments like a barometer, a radar altimeter, gas analyzers, thermometers, and a detachable pod that would serve as a descent module. The idea was that the descent module would parachute down through the Venusian atmosphere and take readings about the composition temperature and pressure all the way down to the surface. In reality, things got a little complicated. Venera 3 experienced another system failure along the way, but the Soviets' aim was true, so the probe still managed to hit Venus like a bullet and slam right into the surface, becoming the first man-made object to ever crash into another planet. The USSR actually scored a hat trick on impacting near-Earth bodies. They were the first to crash on the Moon, Venus, and Mars. There's a lesson in there probably. If you're going to fail, do it historically. Venera 4 in 1967 was the closest yet to a success story. The probe made it all the way to Venus with all systems go and dropped the capsule down into the Venusian atmosphere. From here, the descent module successfully deployed its parachutes and drifted slowly down toward the surface. This was the first spacecraft to ever collect measurements inside the atmosphere of another planet. Data returned by the probe showed something very interesting. At high altitudes, the atmosphere of Venus is very similar to Earth on a warm summer day. Perfectly hospitable temperature and pressure, downright comfortable even. But the lower the probe descends, the more extreme the climate becomes. Not only ramping up in temperature, but in atmospheric pressure as well. It gets so bad that after 90 minutes of slow descent, transmission from the probe goes dead. It's widely believed that the capsule was simply crushed like a beer can by the density of the atmosphere. So now we know that descending into Venus is like diving deep into the ocean, which is a strange concept to wrap your head around. That air could be so dense that it would crush a metal spacecraft. With this new information, the Soviets were nearly certain that their remaining Venera 5 and 6 probes would have no chance of reaching the surface, but they launched them anyway. In the meantime, NASA had launched another flyby mission to Venus with Mariner 5 in 1967. It wouldn't make contact with the planet, but it got close enough to confirm what Venera 4 had experienced, that the conditions on Venus were somehow even more extreme than what had been originally detected in the early 1960s. With that in mind, the Soviets launched Venera 5 and 6 back-to-back in January 1969. Both probes recorded less than an hour of data each before meeting the same crushing fate as their predecessor. And yet the Soviet Union was not discouraged in their efforts. They would simply build even bigger and even stronger probes, and they were going to try again. For their next round of Venera landing attempts, numbers 7 and 8, the Soviets made two very key modifications. For one, the descent module was built from a thicker metal with more insulation from an internal sphere of titanium to protect instruments from heat and padding to soften the blow from impact. And modification number 2 was pretty clever. The engineers wanted to minimize the amount of time that the probe was exposed to the environment, so they put an extra tie around the lines of the parachute. This would stop the parachute from fully opening as the probe fell through the upper atmosphere. Then the material of the tie was designed to melt at a certain temperature that would allow the parachute to deploy at a lower altitude. Although Venera 7's parachute did deploy on August 17, 1970, it still didn't last very long. The material somehow got ripped, or it just straight up melted. Either way, the landing module ended up dropping like a rock, reaching a terminal velocity of 61 kilometers per hour before bouncing off the Venusian surface. Again, based on that transmission, the observers back on Earth assumed that they were looking at yet another failure to reach the surface alive. But that was not the case. Even with a busted-up antenna, the lander was sending back information. And what Venera 7 found would confirm scientists' worst fears. The temperature recorded at the surface showed 475 degrees Celsius, or roughly 900 degrees Fahrenheit, hot enough to melt lead and far too hot for any machine to operate reliably. And yet the Soviets were somehow undeterred. In 1972, they would try it all again with Venera 8. Miraculously, this mission would not face any technical difficulties along the way. The descent module touched down softly on the planet's surface with all of its instruments intact and recorded for just less than 1 hour. So by now we know that the temperature on Venus exceeds 900 degrees Fahrenheit. The pressure on the surface is equivalent to 92 times that of the atmosphere on Earth, which is comparable to being 1 kilometer below water. And if that wasn't enough, the lower atmosphere is filled with sulfuric acid, which is the stuff inside a car battery. Now you would think all of this confirmed knowledge would finally deter even the most committed engineers. But the Soviet Union just didn't believe in quitting. I mean, until they literally quit being a union entirely. Overnight, the whole wall coming down thing. But we're not going there today. Where we are going is back to Venus, because Venera 8 revealed one last fact that was too good to pass up. Even with the dense cloud cover, there's still enough sunlight reaching the surface of Venus to take a photograph, even with the dense cloud cover. There's still enough sunlight reaching the surface of Venus to take a photograph. For Venera 9, the Soviets made a fundamental change to the probe's design. You can see this just by looking at it. There's some crazy stuff going on here. The descent capsule itself has been beefed up yet again. We are now tipping the scales at nearly 5 metric tons, but the standout features have to do with a new landing procedure. Given everything that we now know about Venus, we want to keep our probe's exposure to the environment as minimal as possible, and we also learned that even after being dropped accidentally and plummeting hundreds of meters, Venera 7 still managed to function. So what happens if we drop the probe intentionally? This is what's going on with the 2 rings at the bottom. This is actually the landing gear, or impact ring, just a flat metal circle connected to the main body by a series of shock absorber legs. And at the top is the new aerobrake. This is how we land on Venus with no parachute required. This thing that looks like a weird hat is all that's really needed to get the speed of the probe down low enough for a safe landing. That's putting the incredibly thick atmosphere of Venus to work. It behaves more like water than it does air. It's very trippy. Also, they did technically use a parachute just to slow the probe down in the upper atmosphere, like to get it down to subsonic speed. But the actual landing itself was a free fall straight into the ground from 47 kilometers above the surface. Now, what about those cameras? This is the first photograph ever taken of Venus. It was captured on black and white film by Venera 9 in 1975, and what we're looking at is a field of broken, jagged rocks surrounded by a sand-like material. It's not exactly breathtaking. The photo is only interesting because it was taken on Venus, but I still think it's pretty cool. This is the view from Venera 10, an identical lander that arrived just a few days later. And now we are seeing flat ground with hardly any of those chunks of rock, just the smooth top of what was probably once an ancient lava flow. Venera 11 and 12 were less eventful missions. They failed to return any interesting photos due to lens cap failures. This was one of the tricks with Venus. You have to protect the camera on the way down or it'll melt prematurely. But then you have to rely on an automated system to reveal the lens, which didn't always work. Venera 13, unlucky number, but highly successful mission in the year 1981. This probe returned the first ever color photo of the Venusian surface, and it's one of my favorites. Again, the surface around the lander is just flat, sandy rock, but you can see just a touch of landscape beyond. The probe landed near the edge of a cliff or the peak of a hill. You can get a sense of depth that makes it all seem more real and more alien at the same time. Scenes like this should make every person appreciate the Earth a little more, as most planets and moons in the galaxy probably look like Venus. All of the ones that we've found anyway. Barren, lifeless rocks. Anyway, you can also see the base of the lander again here. And what is the deal with those teeth? They look almost purposefully brutalist, but the teeth served an aerodynamic function. Metal teeth were added to the periphery of the impact ring in an effort to reduce spin and oscillation experienced by previous missions, 11 and 12, which could lead to a pretty rough landing. But that's not all the Venera could do. The probe was also equipped with a drill and surface sampler to analyze the Venusian soil, and what it found was a material very similar to a rock that we call tough on Earth. It's essentially just solidified volcanic ash. Oh, and one more thing. Venera 13 carried a microphone, so we can listen to the sounds of Venus. It's essentially just wind noise and the sound of the probe doing its thing. But again, like the photos, there's something very spooky and alien about it. Venera 14 was again pretty near identical. It found another flat plane of these smooth rocks, which were determined to be very similar to tholeiitic basalt, which is a volcanic rock that makes up most of the Earth's ocean floor. And that was it. That was the last time that a man-made object reached the surface of Venus. There was some really cool stuff done with balloons, but that's a whole other story. What I want to dwell on here is why we never went back. One very obvious reason would be that it's a lot of work and a lot of expense for relatively little payoff. You can send a robot to Mars and it'll last for years, whereas the longest a Venera ever made it was about 2 hours. The Venera program came to an end right as the Soviet Union itself was coming to an end. Leadership and priorities changed. Russia went through a tough time in the 1990s. We're also left with this paradox. Whereas our technology becomes more advanced, it also becomes more fragile. In many ways, the old Soviet Union was the perfect place to build a machine that would withstand Venus. And we may have lost that style of craftsmanship in the pursuit of ever cheaper and more efficient manufacturing. I saw an interview on TV the other day with an old NASA engineer, and he was talking about the Voyager 1 probe. He made the analogy that the computer on Voyager was about as capable as a pocket calculator of the 1970s. Today, we can fit the computing power of an iPhone in our pocket. But does anyone really believe that we could shoot an iPhone into space and have it still operating 40 years in the future? Apple updates alone would make that impossible. But there is a lot that we still have to learn from the past if we truly want to push our space exploration into the future. Subscribe to The Unknown and join the journey into the places science dared to go and the stories the world left behind. Because out there in the void, there's still so much more to uncover.